I feel like I should be starting this lecture with, it was a dark and stormy night out there. It certainly was between here and my home in Boynton Beach. I've done this trip a number of times. I sort of know how long it takes, but this was an adventure. I feel like it was sort of like the questions I was asking of these turtles. Where do you go? And how do you get there? So anyway, I gave this lecture a bit of a generic title when Dennis asked me for a title. But the students who come through my laboratory, which is located in a public park in Boca Raton, often will translate our science in ways that we don't expect. And I am going to be talking about tracking little sea turtles on the high seas. But before we could track them, we had to come up with ways to do it. So this talk is going to have two parts. And one is what the students called sea turtles wearing backpacks. And so the first part is kind of how we get there, how we do science, and kind of the innovation and the creativity process and the learning to take all of the stops off of the way we think about science. And then the second part is what we found out once we figured out how to track little turtles. And so let's start off with the question I get most often. My laboratory is in which we raise little turtles since I haven't been doing work up at Harbor Branch since I was a student. I needed a place to raise turtles, and we run anywhere from about 350 to 700 turtles through our lab each season for various projects. These are animals that come in, we make them work anywhere from days to months, and then they get a ride offshore. So we're not doing dastardly things to these little animals. But our lab has a public viewing gallery area where people can look down and talk to us and talk to the students. And so we get quite a few questions. And if you can imagine a room that's about the size of that bank of chairs over there. And it's full of tanks, and those tanks are full of turtles. And so people get used to seeing little turtles. And then when we let them all go, they go, well, where are the turtles? We came to see turtles. So I took that question seriously for a lot of reasons, not the least of which is, yeah, sure, it's nice to say, well, we gave them a lift offshore, but that's not very satisfying. There's an awful lot of biology that goes on in between where the turtles leave from. So we're letting our turtles go down here. And we know from years of tagging and marking turtles that other scientists who are pretty darn smart figured out that the turtles probably getting into the Gulf Stream, and the next time we see them is over here. And that's just in the case of one species. We get 3 species regularly on our beaches: loggerheads, leatherbacks, and green turtles. And these pictures are all of little loggerheads. And the question is, where are they going? And I'll talk to you a little bit about loggerheads and green turtles today. The assumption is that they were getting in this current and sort of like a turtle race going across the Atlantic and getting out over in the productive waters of the Azores and Madeira and Cape Verde. Okay, so that was kind of the idea, and it's been the idea of where little turtles are going for an awfully long time. The only problem with that idea is there's an awful lot of biology that goes on between here, and we don't know anything about that. So our basic sea turtle life history, as we understand it, is, you may well be familiar that you're in Turtle Central. I call this area of Florida the Turtle Coast. And it's because this is the hot spot for turtles, and I'll come back to that. It's really an important place in the world for sea turtles of all 3 species for nesting. They lay their eggs, they don't tend the nest, the moms go back to the sea, the hatchlings basically incubate at the whims of nature and come out and then have to find the ocean, and then they swim offshore. And where they go offshore and how they get there and what the threats are pretty difficult to figure out because we're not watching them. So I'm going to kind of basically just focus in on that life stage, knowing that there are other life stages that we actually know quite a bit more about. These other foraging ground juveniles and so on. And then eventually the moms and dads come back. Okay, so we're going to be focusing on how to figure out the biology of the lost years. This idea of lost years is simply what I was describing. The turtles enter the ocean and we don't know anything about them until they get over to the Azores. How long does that take? Well, there's a very famous sea turtle biologist named Archie Carr who described this long period between when the turtles leave and when we see them again as a lost year. But it soon became clear it was lost years because those turtles over in the Eastern Atlantic were multiple years old. Okay, so we have this question: why do we care about where our turtles are traveling? And this colored area is all of the area where loggerhead turtles nest in the United States. And the red spots are really high density beaches. So, we're looking at this area in here it tells you this is a really important part of the world for loggerhead turtles. Okay, and I want to put that in perspective for you. Genetically, the turtles that are in the peninsula, that are nesting along the peninsula of Florida are distinct from those that are nesting elsewhere in the US. And we call that the southern Florida subpopulation. That's kind of the unit of conservation that we have. And about anywhere from, depending on which estimate you believe, about 84 to 88% of the loggerheads in the North Atlantic, that's the entire North Atlantic, above basically the part above the equator, hatch here. So what happens in Florida really drives the future of the species. So that's why we care about where our turtles go. Are they going to good neighborhoods with high survivorship? Are they going to bad neighborhoods with low survivorship? Are they going to places that are highly polluted so that maybe they'll survive but not reproduce well, or have some disease events? See, where they go is a critical part of the conservation of the species. And the problem is that it's really hard to know where little turtles go because it's hard to follow them. So basically the question then became, how do we track these small turtles when they are out in the open ocean or they've gone far and wide? So here's the problem I had as a scientist, and I'm going to tell you that I didn't solve this problem alone. I had some wonderful students. I work with a lot of undergrads. If we're working with 300 to 700 turtles, it takes a lot of student help too. And so this kind of work can't be solved by just me and my energy. I also had a colleague, a lady named, still have this colleague, lady named Kate Mansfield, and she was a postdoc down at National Marine Fisheries in Miami. Very bright lady with a lot of technical skills. So she and I basically decided we were going to solve this problem. It's one of those classic examples of you go to a meeting, you sit next to somebody you don't know. Oh, I've heard of you. Yes, nice to meet you. And later that evening, we ended up with some very good rum and some napkins, and we figured out how we could solve this problem. And it sounded really good over the rum, and then it sounded kind of scary because it took us about 2 years to get funding. But eventually it did happen. So that's kind of how science works sometimes. So basically the problem here is that we have threatened and endangered species of sea turtles. And to protect them, manage them, and bring the species to recovery, which is a long-term goal. It's probably going to take much longer than my lifetime. We need to know some sound population information, and that includes what the probable survivorship is, and spatial data. Again, this idea of where are they going, how many are going to this area versus that area. And so where are they? Where are these little turtles going? The big ones, we actually know quite a bit about. That's a big turtle is easy to follow. It's got a big shell. You can put a big tracking device on it, Those tracking devices have big batteries, so they send signals up to the satellites or to the, so you can get GPS locations on some of the big ones. Little turtles can't carry big batteries and big packages. So it's a challenge. It's a technological challenge as well as everything else. So we have a big data gap to solve. Where are the little turtles going? Most of the information we get is from working with nesting turtles. So that big package that we want to, that big platform rather, that we want to put a package of tracking devices on is easy to get to on the nesting beach. But that means we're only really learning much about nesting turtles. If we're lucky, we have a place like the St. Lucie power plant where the turtles are captured and then released. Then we might get some information on juveniles, but it's still big turtles, not the little ones. So the data are limited by turtle size, the longevity. These are long-lived animals. An adult loggerhead probably has a lifespan like you and I have. Funding, of course, is always a big one. Time is a big one. And when an animal is going on an oceanic journey, it's going far offshore. We're talking about tracking little animals with from a long way. So following them by boat isn't very practical either. And so we had to work with available technology, which is changing as we go, but it's not changing as fast as I'd like to see it change. But it did change enough for us to work. Okay, so the first part of this talk is, how do you satellite tag sea turtles? And the reason why we went with satellite tagging is because it had the greatest potential to give us information over long distances. There's a lot of satellite information on the oceanic currents and sea surface temperatures and the productivity of the oceans. So there's a lot of ancillary data that's also collected by satellites. So it was the right technology to look into. So the first thing we had to do was figure out how to use the small scale tags out there. And we're talking about a tag that's about the size of the end of my thumb. Okay, so that's pretty small. And we were able to use solar-powered tags, so somehow that appealed to me as a green technology. We weren't using a lot of battery space on these tags. And so that's a picture of the satellite tag we used. And the antenna has to stick out of water for the satellites to collect the signal, but it has to have enough power to send the signal all the way to the satellite, and then that worked out pretty well. Okay, so we have the tag, and by the way, these tags were developed for birds. And if you think about it, we have a problem in trying to put a tag on a small animal, and people who work with birds have a problem of putting a tag on a small animal. And so that's really the challenge, and we were able to take advantage of what people who study birds, the bird migrations were doing, except their animals weren't going in salt water. Salt water is kind of corrosive, as you guys know. Any of you guys live by the water, you probably know your electric switches don't work after a while because salt air is corroding them. So we're actually talking about throwing electronics in the water and having it function. So we were trying to aim for keeping the tag on these turtles for about 1 to 2 months, which we thought was really ambitious. And then we wanted to have the tag fall off because we wouldn't be there to take it off. So we tried a bunch of different things. The short version of what you're looking at here is a loggerhead turtle wearing a fake tag. We ended up using real fake tags as well as surrogates that we made out of wood or plastics. And we did the surrogates because even the non-functional tags were $250 a piece. And after a while you start to say, well, I can find something the right shape and weight and glue it onto the turtle and see if it'll stay or if it causes any problems. So that was turtle 306 wearing a fake tag. In this case, it had epoxy on its shell. Okay, so we were able to, in this laboratory, take advantage of other reasons why the turtles were there and basically develop these methods for tagging the turtles and test them in the lab and make sure the turtles could swim normally and feed and all those things. And then after we did that part, we could field test, which means take the turtles out and let them go and see if we got data, which was kind of a scary thing to do because those satellite tags were about $3,500 a piece. So yeah, miniaturizing things and throwing it in salt water, as soon as you miniaturize, you kind of like add an extra zero to the end of your price. And as soon as you tell the guys who make them, you're going to put it in salt water, they add another $300 to the price. And so anyway, but we were lucky. We were able to get several funding sources to put together and get this project done. And the whole point of this was so we could identify the offshore nursery areas. Where are these turtles going to grow up? Not just getting to the Azores, but what's the biology along the way? Where are those nursery areas along the way? And what are the offshore routes that these animals are taking? Are they just riding the currents or are they doing something else? So a lot of our problem solving came down to trying to accommodate the rapid growth of these neonate turtles. And you don't recognize just how fast these little turtles grow. They start off about that size, and by the time we let them go, they're about that size. And that's a period of anywhere from 3.5 to 6 months, okay? So that's pretty rapid growth. And so that told us that whatever we put on them had to stretch for a little bit. We also had these tags, as you can see, kind of up here, or over there. Okay, this is a loggerhead. Loggerheads always have this spiny ridge down the middle until they get to be adults. And so that's not exactly a convenient thing for us to work with. All right, we wanted to streamline those tags because we weren't sure if we were going to cost the turtles extra energy. And then when we worked with green turtles, we had another problem. Basically, on green turtles, we have a problem with their backs being too slick. I call green turtles Teflon turtles. Nothing sticks to them. So we were, and whatever we used to put these tags on, besides streamlining it and making it stick and then making it fall off, it had to endure the hazards of sea. We couldn't put something on the turtle that would cause it to not be able to feed or get entangled. So it was a bit of a challenge. Okay, so basically, where do you start? All right, well, we start with what we know from adult and large juvenile turtles. You take a tag and you, well, most people don't use Velcro, but I do. I use it in the lab to put turtles in tanks and try to keep them restrained from where they want to go versus where they need to go. So we tried Velcro and Vet Bond, which is a surgical adhesive. That didn't work so well. We'll come back to that. We tried Sonic Weld, which is a kind of epoxy. A lot of people use Sonic Weld on turtles because you can mix it up and it doesn't get too hot. And it works pretty well on larger turtles. And then we tried silicone and neoprene. And the silicone was a sticky glue like you use in your bathroom or on your boat. And the neoprene is like a wet piece of, matter of fact, it was a piece of old wetsuit. And the idea was the tags weighed about 9.5 grams, and we wanted to just give it a little buoyancy to counteract that. Okay, so those looked like reasonable places to start. Pretend it's a boat, pretend it's an adult turtle, or pretend it's one of my lab turtles. None of those worked. Okay, so they either caused the shell to not grow normally, or they weren't strong enough in the case of the Velcro, and the neoprene and silicone came off. And so none of these things were considered okay. So then take off the ideas that are traditional and try something new. So then we tried new epoxies. There was a whole bunch of new epoxies out there. And then we tried different kinds of silicones, but this all basically started to gel when I realized that, or remembered actually, that the shell is made out of the same stuff as our fingernails and our hair is made out of. It's keratin. And so I know that nail salon people keep nails on people, including my husband. And my husband is a biologist. He also gets into the sand and he gets into the and seawater, but he has one hand with acrylic nails on it because he plays guitar, and he has to keep a decent set of nails to play guitar for his relaxation. So I called up the nail salon lady, and they said, "How do you keep nails on my husband?" And she says, "Oh, that's easy." And I'm going, "Okay, tell me more, tell me more." And she says, "Oh, I just buff them up really good, and then I put an acrylic base coat on, and it's just fine." I said, "Oh, cool. Can I do that to turtles? You want to come over?" And she says, "Nah, I don't want to come over." But she was afraid of turtles at that point in her life. But anyway, she told me what she did, and so I thought, okay. So I buffed the shell, and then we put an acrylic base coat on the shell, and then put our epoxy on and our neoprene. And golly gee whiz, it worked. So I called up the nail lady and I said, "You're a genius." So she starts thinking this is okay now. We also tried something else. We also tried harnesses. And we were actually asked by the federal government folks to try harnesses because a lot of people use harnesses to attach tags. And so we used what was called, my colleague Kate Mansfield really likes to name things. She calls it WYNEKEN harness with neoprene. There's our turtles sporting that. This was a lycra harness, like a bathing suit, with neoprene just to buoy up the tag a little bit. This was a lycra swimsuit with sutured seams. We have wonderful students that come through, and you never kind of know their backgrounds. So one of them who came through, actually, I think she ended up coming up here for semester by the sea. I knew she was a mature student, which means she was a little older than 19 or 20 or 21. And it turns out she has an undergraduate background. Her first undergraduate background was in fashion design. And I'm not making this up. So she fashioned this suit, and it had little sutures and seams, and so the thing would have a wardrobe failure at some point. All right, and so that we felt we were being really clever, and so we put a real dummy tag on that one, none of our surrogate tags. Okay, so, but Kate also likes to rename these things. This was the Borat suit. This was the Esther Williams, and that was the James Bond because it was so high tech. Forgot she gave me that slide. Okay, the Borat didn't work, it was too buoyant. The Esther Williams didn't work because it didn't fall off. And the James Bond just never failed. So we couldn't use any of those. So no harnesses in our future. So we kind of went back to this, using the silicone and the neoprene with the acrylic base coat, and that worked out really well. And so basically we had our tags attached with stretch, the silicone, and durability, and that came from the acrylic and some of the silicone. And in order to demonstrate that we were actually, this is Kate Mansfield here, very clever techno geek lady. And that's our durable, stretchy attachment. We had to actually go through and look and see how our turtles with tags did relative to turtles without tags in terms of their growth. And this is grams per millimeter of growth. And basically, the different colors, those are our tags, and the blacks and grays are the turtles without tags. And so statistically, these are actually not distinguishable because there's also some black and gray in here. And so basically, we were able to say that we were, with some confidence, we were having minimal effect, and certainly biologically not significant effect on these animals. So that was another critical thing. Okay, so what worked was our silicone, neoprene, and acrylic. We had a tag duration once we did a field release of these animals of 30 to 204 days. And this is just the loggerheads. I'll show you the green turtles in a minute. And it was really pretty striking how well this worked. So we were able to show that the animals in the lab would feed normally until and after the tags came off. They were growing normally. They were diving normally, which is not a lot. They don't dive a lot at this size. We had really good duration on our tag attachment, and it shed cleanly. You'd come in one day, and the tag would just be off in the bottom of the tank. So that was what we needed. Okay, and so this was our first tag release. We were able to go out to the Gulf Stream, release our turtles, got in the water, and looked at them, and hooray, finally they're released. And then the cool thing about these satellite tags is they're set up to send a message home. So I'd get an email every 2 days saying, I'm here, here's my coordinates. So it's kind of like the kids are calling home to say they're okay. So that was kind of fun. All right, and so how well did these work? Remember, these are 9.5 gram solar-powered bird tags, and the extra $300 a tag was so they could put extra epoxy on them. Here you get a feeling for how big these tags are. And this was one of our release turtles with the front of the tag there kind of sloped so that it cut down on some of the drag. Okay, so there's several ways you can evaluate the performance of a tag, and one of them is simply asking how good are the messages that are sent home to, from the satellites. And those are receive Argos location codes, and these are the good ones, and these are the not so good ones. So about 70% of our messages from the satellites were really, really high accuracy, and that was really good. That was an excellent thing to have. So we had good accuracy. We also got lots of messages. That meant that the antenna was at the surface, and was at the surface long enough time for the satellites to get the messages and then send them home. And then we also knew that our solar cells were optimally charging. It also sends part of the signal message is I'm here, and here's the voltage on my from my solar cells. And it also told us what temperature water they were in. And so these are temperatures, daily temperatures in degrees C. So 25 degrees C, that's in the upper 70s. And what you see is this kind of thing. These lines down here are the two different models of sea surface temperature. So what this tells us is that the turtles are warmer than sea surface temperature. So that was kind of interesting and I wouldn't say puzzling, but it led us down another direction of how to use this information to tell where the turtles are, what habitat are they in. And this brings me to part 2 of this talk, which is, where do these little turtles go? And remember the question is that this is a turtle race through this circular current system that can drive the way things move around the Atlantic, or were they going into the Sargasso Sea in the middle of this? And again, we're looking at this first part of the lifespan after the hatchlings go out to sea. So each one of these colored lines here's our turtles released off of Florida, and each one of these colored lines is where the turtles went. And we actually had one additional tag that we put out that only transmitted 27 days, but we still had a very good transmission series. And you can see a few of them went kind of a little bit out towards Bermuda, but most of them were basically traveling up in the Gulf Stream current. And once they got to North Carolina, they started to do very circuitous routes. And then they'd sort of start across the North Atlantic drift here and up towards some of the important fishing grounds. And the ends of the lines are literally where the tag stops transmitting. Okay, so basically the turtles are remaining over the continental shelf until about North Carolina, and then they depart from that and go out into the oceanic waters, pelagic oceanic waters. Another thing we learned was that they were traveling pretty fast. So the time to that departure from the continental shelf was only 11 to 19 days. And that was pretty good. That's a pretty good features. So they're using that current quite a bit. Now, if we look at the green turtles, remember those are the Teflon turtles, we had to go through that same tagging, testing materials, and just about everything we learned from loggerheads we could not use on green turtles because their shells are slick. They don't. They're thin. The keratin is real thin. You can't buff it down very much, and we ended up having to rely on some marine adhesives. Green turtles we got 10 to 195 days. So 10 days is really low. That was disappointing. The 195 days was really nice and high. That was really good. So, but we averaged 2 months keeping tags on green turtles, which was stunning. They also traveled huge distances. Now, one of the things that was kind of interesting is just like our loggerheads, they're remaining in the warm sea surface. They were remaining at about 21 to 25 degrees C. So a little cooler than some of the loggerheads. And they were pretty much constrained by the western edge of the Gulf Stream, so they weren't wandering in towards land very, very much. Okay, so when we ask the question, what oceanographic features were they using? In other words, where are these turtles? We can say with confidence that they were using the currents, that Gulf Stream component. They were also using some of the eddies, and I'll show you that in a minute, and they tended to be in warmer waters. So when we first were getting messages from these turtles and we were seeing that they were up at the latitude of Maine, that kind of got my attention. And then I remember how when you get offshore, there's actually some pretty warm water. So this is basically a track, and the track data come in, remember, every 2 days. So we'll get dots here, and then dots here, and then dots here. And the background is the sea surface temperature. So the warmer colors, the yellows and the oranges are warmer. The oranges are warmer than the yellows. And you can see that the turtles are pretty much staying in the warmer waters. And there are some eddies, which you see as these swirls, and I'll come back to those in just a minute. These animals were also, the colors of the dots change with the time at large. So this is a turtle that decided it was going to go to Bermuda for the winter. And it kept its tag a nice long time. And this is basically that turtle that went around and hung around Bermuda for a while and then came back. And all of these dots that are really close together, it's not moving very fast at that point. And it's also it kept its tag longer than some of the other turtles because it was in somewhat cooler water than some of our other turtles, which means it wasn't growing as fast. So the loggerhead that did that. Very, very neat. Some Bermudas right there. You guys who lived in Bermuda for almost forever, you've had turtles. You've had loggerhead turtles in your water. Not green turtles. I know they're there too. Okay. All right. So let's talk a little bit about some of these are all of our loggerhead tracks together, and you really can get a feeling for how close that one turtle got to the Azores. All right. But that was the exception. Most of the turtles are taking lots of meanders around the way, and this work is now out in publication. My colleague, Kate Mansfield, was the lead author on this. We worked with an oceanographer as well to characterize these waters, and so basically the red colors are 30 degrees C. That's really warm water. You wouldn't want to, well, you would swim in it, but it's pretty warm. Most of the time, the turtles were staying right around 25 degrees, okay? But occasionally they'd get into these cooler waters, and the cooler waters are going to slow their growth a little bit, but there may be an advantage to being in those cooler waters, and there may be ways the turtles could compensate for that. So one of the ways they could compensate for it is getting into sargassum. And basically, we wanted to be able to see if there was an impact of getting in sargassum. So we did a really down and dirty bucket experiment. So we took seawater and sargassum and seawater without sargassum and put some of these black temperature data loggers in it and another data logger there and put them in pools of seawater to simulate what was going on. And what we were able to do was look at those impacts of the water and the water around the sargassum on temperature. And what we were able to find was basically, these are temperature models that a colleague from Wisconsin, well known for its marine biology, Warren Porter did for us. And basically what he's looking at is the difference between the air or the water temperatures in these two buckets. The area with the temperature logger is either free in the water or below the sargassum or below down into the bucket. And what he's showing is that there are periods where it would get quite warm and a few periods where it got a little cooler. Now this period where it got a little cooler, I was concerned about that. That turned out to be a raccoon came into our experiment and went digging around, and so we had to put that temperature logger back in, and then it started behaving normally again. So that was, no, we continue, it's real. So, and this was a temperature difference in the mid-water, in other words, without the water below the sargassum, and you've got bigger oscillations, but it still basically told us that if the turtles can be in cool water, but if they're in the sargassum, they're likely going to be a lot warmer. And that was consistent with what those temperatures we were getting from the tags, where the tags were warmer than the surrounding sea surface temperatures at some of the time. Okay, so what is the probability that they're going to come across sargassum? Well, there's a really neat paper that was done in 2011 that showed where these bigger masses of sargassum are. And what we were finding was that the turtles were, during part of that time, visiting those areas. And that was really, really cool. So we could also relate this back to where the sargassum was located during the times the turtles were out there and moving through the oceans. Okay, I told you I was going to talk to you a little bit about the currents. So here's one of the turtles. It's easier to look at one line, and basically its route. And this box here is blown up, and what this is showing you is that this turtle basically came along and skirted the edge of this clockwise eddy. And that's really, it turns out it's really common for older turtles to do this. We didn't know that younger turtles could take advantage of these edges of these eddies. Those are areas that are fairly productive. And this area in here is this box here. And that's a turtle that's basically going between two eddies. This one went along this clockwise eddy, and then actually kind of pinged around off of an anti-clockwise eddy. This one effectively came along here and moved around the clockwise eddy, and here's the anti-clockwise eddy. And moving between those eddies is a behavior that is liable to put them into the most productive areas. And so we were pretty confident that they were going to good places to feed. They were staying in water that's warm enough to grow. And the turtles that were in the cooler water kept their tags longer than those in the warmer water. Okay, so if we put the two species together, we find that they basically are doing the same kinds of things. And that was, they're leaving from the same beaches. And we're seeing that they're using this current to pretty much get them up along to the North Carolina area, and then they depart. Some of the green turtles come out of this cross the Atlantic current a little sooner than the loggerheads. They're a little stronger swimmers. They may be selecting slightly different habitat, but that was a nice thing to discover that they're sharing some features in common and then departing in some ways as well. Okay, so what we got out of this was we had the first long-term tracks of any green turtle. This is a green turtle. For both species, we identified the importance of the Gulf Stream current and gyres, that circular system of currents across the Atlantic in their initial dispersal. One of the questions was, do the turtles go out and come back, go out and come back? Both species were looking at unidirectional movement with that current. And that was kind of expected, but it's nice to be able to put data behind it. The turtles were basically associated with the western Gulf Stream frontal systems, which was again sort of something you would expect, but they could have gone more towards the east and didn't. We were able to demonstrate with those tags and their charging rates and their number of hits we were getting from the satellites that animals were living in the surface habitat. Again, that was a question. There was one of the concerns that we had to deal with was that these tags might be high drag, but if they're up at the surface and out of the water, air is a low drag medium compared to water. And this turned out to be a really good tracking method for little turtles. And it's now being used in loggerheads, green turtles, Kemp's ridleys, and hawksbills in the Gulf of Mexico in response to understanding what some of those impacts of the Deepwater Horizon. So it's been a very nice journey as a scientist, and it's been a nice journey to learn about where those turtles are going. And as you might expect, these kinds of studies take a lot of money and a lot of effort and a ton of assistance, and I couldn't put the 80 undergrads that have helped over the last 7 years on this project. So I just want to recognize a few of them. And this was our first batch of students with turtles to release. So, and there's one of our turtles. Okay, if you have any questions, I would be delighted to try to answer them.